Hi everyone. So today we'll be discussing uh, permutation of rows and columns. This is basically a question E. This is question E of Codeforces Round 950, which was a div 3, and it's a recent round. So I expected the question quality to be very good. Maybe it is, but I personally found it to be on the easier side. It's rated 1600, but it's honestly one of the easiest 1600s I've ever solved. So let's start with the question. You have been given a matrix A of size n by m containing a permutation of integers from 1 to n into m. A permutation of n integers is an array containing all numbers from 1 to n exactly once. For example, the array 1, 2, 1, 3, 5, 4, 3, 2, 1 are permutations, while the array 1, 1, 100, 1, 4, 5 are not. So this is nothing but it's just explaining you what a permutation is. A matrix contains a permutation if when all its elements are written out, the resulting array is a permutation. Matrix is 1, 2, 3, 4. So this is basically one matrix. So this is a permutation because it's a 2 into 2 matrix. So elements from 1 to 4 should occur at least once, and that is exactly what's happening. Whereas something like this is not a permutation because there's again 2 into 2 elements in this matrix. This is a matrix, double brackets basically, and there have to be 2 into 2 columns here, but they're only the 1 and 2 are being repeated here, so this is not a permutation. You are being told that you can do two actions in one operation. You can choose any C and D columns, and you can swap these columns, and C and D should not be the same. So basically you can choose two different columns and you can just swap them, or you can do the same with the rows, right? You can choose any two different rows and swap them. You can do any number of operations, and you are given an original matrix A and you're given an original matrix B. Your task is to determine whether it is possible to transform matrix A into matrix B using the given operation. So the test cases, the constraints are given pretty standard. Basically you can run a O of n square pretty easily. You can do a O of n cube, I think, or more, I do not know, because n into m goes up to 2 into 10 raised to the power 5. So basically n at max can be root of 10 raised to the power 5. So roughly 10 square, let's assume 10 square is 100, right? So 100 square is what? 100 square is 10,000. So basically 10 raised to the power 4. So you can do O of n cube at least. It can go up to 10 raised to the power 6. Because O of n raised to the power 4 will be 10 raised to the power 8, which will really. So just discussing the time constraints. So yeah, you given n lines containing n m integers. So basically n into m elements which are part of matrix A, and then again n into m elements part of matrix B. And you have to print yes if the second matrix can be obtained from the first, else no. So let us pick some sample. So let's start with this. So yeah. So basically this is n and m, and then we are given two matrices. This is matrix A and this is matrix B, right? So we want to check if A can be converted into B. So yeah, if we just we just simulate the operation that if we can do it or not. So 4, 3, this row can be shifted up. So this new column will become 3, 4, 1, 2, and then 4, 2. This column can be shifted, can be swapped, sorry, with this 3, 1 column. So this then the new matrix will become 4, 3, 2, 1, which matches B. So yeah, this is the question in a nutshell. Now there are some observations that I was able to make in this question, which are quite honestly very intuitive. So the first observation is that let's say you have any row A, B, C, right? Let's say you have D, E, F, A, B, C, D, F, G, H, I. right? As I was saying, if you have any row ABC, right, and you want to swap it with any another row basically, so the thing to notice is that if I basically just swap ABC and DEF, right, I put DEF above and then I put ABC in the middle, the elements within this ABC row, they do not essentially change, right? If I'm picking the entire row and I'm moving it anywhere, like any number of times I'm moving it anywhere, the elements within this row remain the same, right? This also remains true for all other rows. If I'm swapping any two rows, the elements remain the same. Does this also hold for columns? We can also check for that. So ABC, D, E, F, G, H, I. So let's say if I pick this column CFI and let's say I want to swap it with this BEH column, my bad. So CFI, when I'm swapping it with this second column, these elements in the third column will remain intact, right? Also when when BEH will be shifted here, the elements within this BEH will also remain intact. So what we notice here is that if we move any row or if we move any column, the elements within the row or column, they stay same, they do not change, right? Now some more observations that we can do from here only is that let's say I have again ABC, DEF, GHI, right? So if I am shifting ABC to DEF, what exactly is changing? The row elements stay as it is. The column elements, however, they change a little bit. How do they change? Earlier ABC was here, now ABC is here. The middle element moved from here to here. So the thing is that the elements within the column, they remain the same, right? It was BEH before, it is EBH now in the middle column. The elements across the column remain same. However, the permutation that in which they occur, it changes, right? Similarly, if you take maybe if you are trying to swap columns, let's say I have column CFI and then I have column BEH. If I swap these two columns, so if I basically make this C, if I make this F, and if I make this I, right? So CFI we have shifted here, cool. Yeah, so if we basically so yeah, if basically this becomes new column, we have shifted CA5, which was earlier the third column, to the second column. The thing to be observed is first, which we already discussed, that the column elements remain constant. It was CFI here, it is CFI here too. However, the thing that changes is the row elements. The row elements in themselves do not change. It was A, B, C earlier, now it is A, C, B. Right, it was D, E, F earlier, now it is D, F, E. So the column elements also remain same. However, the permutation in which they occur, that might change, right? So what can we infer from all these observations? If in my matrix A there exists some numbers like 1, 2, 3, let's say, and 4, 5, 6, 7, 8, 9, something like that, or let's say let's pick some example from the sample test cases only. Yeah, so basically this is M, and these are our two matrix. So yeah, as we were discussing, if this is our input matrix A and we have to make it B, right, we know that we basically know that the row elements that are present in A, right, if there's like 159 present in A, then no matter how much I swap this row, or how much I swap any column, there should also exist a array, or a line or row in B which should also contain 159, because no matter how much I swap any row or any column, these the elements within my row, they do not change. This we have already discussed previously, right? Because if I swap row with any other row, these columns do not change altogether. If I change columns, if I swap columns, the order that is there in the first row, that changes, but the elements in the row remain the same, right? So as long as there is some row in A and there is a corresponding row in B2 which contains the same elements, the permutation doesn't matter. The permutation, as we have seen, it can be changed, right? If I swap columns, this 159 can be changed to, like, maybe some other permutation. So as long for every row in A there exists an equivalent row in B which also contains the same elements, and similarly for every row, every column in A there exists a counterpart column in B which also contains the same element. For example, 163 here, 163 here, 927 here, 927 here. The order could be a little different. That does not matter. Like, for example, this could be like this. So 927 exists here, 972 exists here too, right? The elements should be the same. The order does not matter because the order can be changed. So because this condition satisfies, therefore it is sufficient to prove that A can be converted into B. So yeah, this was all about the idea of this problem. Pretty simple, right? That initial observation that no matter which row you swap any row with, the row elements do not change. Even if you swap columns, the permutation within a row changes, or it might change. It's not necessarily it changes, it might change. However, the elements that are within the row, they stay the same, they do not change. So yeah, this was the idea behind this problem. Now I'll be moving to the code part. So yeah, now we start with the code part. I've taken nm, the size of the array, and then I've taken two 2D arrays A and B, which are provided to me in input. The first base condition that I've written is if n equal to 1 or m equal to 1, print yes, py print yes, and then return. The reason being very simple. If I have some permutation of 4 elements like 1, 3, 2, 4, and then I have 1, 2, 3, 4, right? Since we can just swap any element any number of times, so simply any element can be considered as a column, and it can be switched multiple times to derive this row. I think that will be pretty clear. And similarly, the same can be said for if there's a single line of columns, right? So that is why this condition is there. Then yeah, now the further logic is pretty simple. So let's say we have this array A and then we have this array B, right? We know that 159, if it exists in matrix A, then it has to also occur in matrix B. The order does not matter, right? So they just have to be the same. It's as simple as that. So how do I ensure that I'm comparing arrays in both matrices? And and since the order is irrelevant, what I can do is that basically I can just sort each row in A and then sort each row in B. So sorted after sorting rows in A, this will become something like 159, then 246, and then 378. So this will how A will look. And then after sorting rows in B, it will basically become 159, 378, and then 246. Now 159 is present in A and 159 is present in B. 378 is present in A, 378 is present in B, and 246 is present in A and 246 is present in B. So since all elements that exist in all rows that exist in A, they exist in B too, therefore the rows part match. Similarly, we'll do the same for columns, right? For each column we can simply sort the column. All columns in A we can sort them, and then all columns in B and we can sort them, and then we can check if they're equal. Again, the question might come that why are we sorting? The idea behind sorting is very simple. I just want to compare if rows in A and rows in B are simple. The permutation to me does not matter if it is 1 2 3 or it is 1 3 2. It is irrelevant. I just want to check if 1 2 3 exists or not. So if I simply sort 1 2 3, so in A also I'll get 1 2 3, in B also I'll get 1 2 3, and it will be very easy to check if they are same or not. So yeah, so that's basically what I've implemented in the code. Yeah, so we basically make a VBI a row, and what we do is we just take VI a vector named cur, and we just push all elements of the first row into this cur, and then we sort all cur, and then we basically push this sorted row in the new 2D vector A row that we have made. Similarly, for all rows in A, we sort them and push it into A row. We do the same thing for A column, and then B row, and then B column as well, right? And in the end, I sort everything up. So to ensure uniformity in matrices A and B. So basically, it's something like this and this. So what will happen is that it will become something like this. So now what happens is if they are both equal, they become exactly the same. And then we simply check if A row equal to B row and A column equal to B column, then print yes, else print no. And yes, this works on our sample test cases. Why is it slow? Oh yeah, so passed. Yeah.